Good evening, everyone, and welcome to New York Metro Weather's forecast discussion for December 5th, 2011. We have a lot to talk about today, or tonight, with a frontal boundary approaching the area. The unsettled weather expected to be a significant factor during the week, not only Tuesday and Wednesday, but now also on some of the models Wednesday night into Thursday. We'll get to that a little later. Right now, we're looking at the current picture. You can see higher pressures are moving off here to the east out over the Atlantic Ocean, while lower pressures are here along the frontal boundary. And you'll notice the front, because if you look at the wind barbs, here we have a southeast flow, and then you can see back here on the other side of the front, higher pressures and the winds blowing out of the northwest with some cold air coming in over the Great Lakes. So these scattered showers are expected to move towards the area with clouds already on the increase. And if we take a look at the NAM model for tomorrow, you can see here on these four panels a few very important things. Number one, the lower pressures here, these solid black lines, are actually extended along the front. So this is where the front is, and it makes sense when you look here at the top right panel that that's where the precipitation is, near the front. And notice these excuse me, notice these solid lines. These are the 850 millibar temperatures. And you can see that there's a gradient just to the west of our area. So they're 10 Celsius near west central New Jersey and eastern Pennsylvania. But as you go over to northwestern Pennsylvania, there's a 0 Celsius line, and then you get into negative 3, 4, 5, 6, 7. And if we go down here to the bottom of the chart, you can see on the bottom left, these are the just above the surface winds. Right here is where you have these streamlines converging along a frontal boundary, with the northwest winds behind the front and the south winds ahead of it. So these showers will be around, for the most part, Tuesday and Wednesday, with clouds near the area. And you could take a look here, even you could loop the NAM model if you want, and you can see that these showers are around for the most part as the front begins to approach the area. And if you were to take a look at the simulated radar, which we have the availability of doing so, here we are with the showers moving in and around the area. This is Wednesday morning, continuing through Wednesday, and then we get into a little bit of a break, some more stuff Wednesday, and then some more significant stuff you can see building down south, which we're going to get into right now. So that pretty much takes us to the Wednesday forecast. Temperatures still pretty mild, temperatures in the 60s, dropping into the 50s on Wednesday. But here's where we want to start taking a look at the pattern. Here's where it is right now. This is 500 millibars and vorticity on the top left. You can see a strong shortwave here over the southwest states, and here's the scattered shortwaves along the front. So here's what happens. You can see the shortwave moves down through the southwest states, elongates a little bit, and then breaks off to be its own feature. So now we have a very strong shortwave here around the Texas Panhandle. This is Wednesday morning. You could look at all four maps really. The top right is the surface pressure. The bottom right is precipitation over the last 6 hours. The bottom left is the 700 millibar heights and relative humidity. So here's this shortwave elongating, and now watch as this shortwave really begins to strengthen over Texas, and it closes off here, this closed contour. This is a very strong feature. And it's then forecast to actually shift eastward within the upper level flow and move off the coast. And now if you were to look here on the right, top right panel, there you go. This shortwave has moved to the north and east and has allowed a surface low to develop. Now you'll notice this shortwave is weaker. It's what we call de-amplifying. So it's not as strong as it was earlier as it moves to the east, but it's enough to allow the development of a surface low along the front. Now here's the precipitation on the bottom right. You can see an area of enhanced precipitation near the New Jersey shore in New York City, and up and down the whole entire east coast for the most part. And the 700 millibar relative humidity shows that as well. Here is the close-up view. That was the 12Z NAM that we were looking at. Now here's the 18Z NAM. We'll roll through it. Here's the showers Tuesday and Wednesday, and then you'll see a more significant system coming up the coast. Initially, this is where the forecast gets very complicated, because we could actually be dealing with frozen precipitation types, and that's what's something we definitely didn't expect. But notice what's helping to develop it: the surface front. Look down here over near the Washington D.C. or south of Washington D.C. here on the top right panel. Look at the gradient here. I mean, over a few counties it goes from 10 Celsius at 850, and we talked about these 850 temperatures before. It goes from 10 Celsius at 850 to 0 Celsius. So although the 850 temperatures aren't the know-all tell-all for snowfall, you can see temperatures are still in the 40s here, they are a good indication as to whether or not you are even close to having frozen precipitation in your area. So we'll look what happens here. Through 60 hours, the precipitation is really starting to get heavy, and you can see on the top left, temperatures are cooling. It's around 40 degrees here Thursday morning in our area, and then by 63 hours, look at the cooling that occurs. We're near zero at 850 millibars. The interior suburbs are below that. What the models are showing really is some very impressive dynamic cooling, with the surface low down to 996 millibars southeast of Long Island. That's early Thursday morning. So the NAM is definitely an outlier to the north and west right now, but we're still 60 to 72 hours away from this event. We're making this video obviously Monday evening, and the storm would be Thursday morning, Wednesday night to Thursday morning, so we have a lot of time. But to see this feature right here is very important, the strong surface low, and then to see this gradient and the way the storm develops really argues that the potential is there for rain transitioning to heavy snow for a few hours in the area. Here's a better regional view where you can even see the shortwave on the top left. We talk about it. It's coming from the southwest, technically a southwest flow in the middle of the atmosphere, but then it redevelops along the coast, and you can see right here in the top center panel there's your surface low, and there it goes shooting and redeveloping off the coast, actually pretty close to the coast on this run, as we mentioned. A little warm to start, but this run provides some pretty significant dynamics and precipitation over inland areas of northern New Jersey, southeast New York, and even Connecticut and eastern Pennsylvania, and then moving down into the interior suburbs as the storm continues into Sunday morning. These maps are not the most accurate, but just for argument's sake, if you were to take the 18Z NAM, which was run this afternoon, so this afternoon's model runs, you can see the sharp cutoff. New York City, we'll go down here to the scale for you, around 2 inches of snow according to the NAM, and then as you get further inland, just on the west side of the Watchung Mountains, higher than 6 inches of snow and 8 to 10 inches of snow over the mountains of northwest New Jersey into Orange County and then back into Litchfield County, and even the immediate suburbs with 4, 5, 6 inches of snow on the NAM itself, which happens to be warm to start. Now the problem here is we're walking a very, very fine line, and we'll talk about it right here. This is what we call a forecast sounding. So we're looking at the atmosphere top to bottom. So right down here, right where I'm circling the arrow right now, is where the humans are, where we live, where our environment is, right in the very, very bottom of the atmosphere. It's what we call the boundary layer. So that's where we experience our weather. Further up, as we go further up through the atmosphere, here's 850 millibars. This is the temperatures we were looking at earlier. Here's, as we go further up, 500 millibars, and then as we go higher and higher and higher into the atmosphere. Now, the freezing line in the atmosphere, you can see this zero right here, it actually runs like this. So it runs down at an angle to this zero. Okay, so if we look at this sounding, this is a sounding just north of New York City, on the NAM at 63 hours, which is valid 9Z on Thursday morning. And you can see this temperature, the red temperature line, is running very close to the 0 Celsius line, especially right here on 950 millibars. Very close, is what we call a warm layer. So although the 850 millibar temperatures are around -1, -2 here, you can see that as you get towards 950, you get closer to that 0 Celsius line, and then a little bit of a cooler air mass just above the surface. So what we really could be dealing with here is another situation where it rains to start, and then the transition begins to occur, but it's not a full transition as you would typically see. Rain goes over to snow and stays there. With such borderline temperatures, when the precipitation lightens up, it could go back to rain, and when it gets heavier, it could go back to snow. So it's something to consider. Now, just for the heck of it, we're going to go here and zoom in on this map here and go into northwest New Jersey. Now keep your eyes on this sounding, and we're going to flip to a new sounding here over northwest New Jersey. We're going to plot this and pull this up, and you're going to notice the differences in how much colder the air is over inland areas. Look how much further away from the 0 Celsius line we are here. Really, the only area that's near zero is right near the surface. The rest of the column here, all the way up through 500 millibars, is below 0 Celsius. The other thing we wanted to point out is getting a little bit more technical, but right here between 500 and 700 millibars, there is a little bit of a disconnect between the dew points and the temperatures in the snow growth region, which is something really to keep an eye on forecast soundings, because it could mean that the snow growth is more poor than we originally thought it was. So even when the transition occurs, it could be hard to produce good snowflakes in this setup. We haven't looked at the GFS yet or talked about it. Here it is for the storm we were just referencing, and you can see it has a storm farther to the south and east than the NAM, not as close to the coast. So immediately your reaction, if you follow the weather, would be, oh, okay, that must mean it's colder because it's not closer to the coast and bringing in as much warm air. Excuse me. Yes, you're correct at 850 millibars, but guess what? Without the dynamics to dynamically cool the atmosphere, it's actually warmer at the surface and in some spots through the boundary layer. So the GFS gives the area less snow than the NAM. So this is where we're dealing with things that are pretty complicated with dynamics and the track of the system. And like I said, we're walking a very fine line here. As far as consistency, we look at the GFS ensembles here. This is all the GFS satellite members. If you're not familiar with weather models, there's one main operational model, which is one we just looked at, which has the highest resolution, and then it has ensembles or satellite members, smaller, lesser resolution members that usually are created to make a mean solution, to say, okay, its ensemble members are either doing this or this compared to the operational. In this case, most of them are fairly similar to the operational. You can see a few of them are more amplified like the NAM, and a few of them are farther south and east. But really the point here is that we're walking a very fine line as far as winter weather is concerned from this system, because we need the system to come close enough to give us dynamics to cool the column, but it can't come too close because it will get too warm, and it can't go too far away because even though the system will be colder aloft, at the surface we won't be able to cool down enough to get snow. That was the 18Z, or the afternoon run to the GFS, was a very good example of how fine of a line we were walking here, because although the shortwave is taking a decent track, the GFS has that surface low just a little bit further south and east, so we don't get the dynamics into the area, we don't cool down, the snow doesn't fall. So what we're going to include in our forecast for right now is a potential for advisory level snows 1 to 3, 2 to 4 inches right now, which actually falls a little bit below advisory criteria, but we'll mention it anyway, over the interior, away from New York City, because near the coast and where the boundary layer is warmer, we have much more concern as to whether or not things will be able to recover as a transition occurs from rain to snow on Wednesday night into Thursday. That's the timing for the storm. I don't know if we went over that yet. Wednesday night going into Thursday morning. And here's a little map we drew up. Not too much detail on it yet, as you can see. But basically, if you're shaded in blue, that's where we feel the potential exists for a few, potentially a few sloppy inches of snow. And if you live in the higher elevations, there is a potential for advisory level snowfalls from this system. So that's all we really got for you today. We urge you to stay in touch, keep following us. We'll keep you guys updated. Usually when storms get close like this, we like to update more often and more rapidly, and keep everybody informed as to what's going on with each model run and each cycle that we get. So stay tuned. We'll keep you guys updated, and if anyone asks you, tell them that the potential does exist for some accumulating snow Wednesday into Thursday, but there's a lot of uncertainty. Right now it does not look like that big of a deal. But stay here, we'll keep you updated, and we hope you guys have a good Monday night, and we'll talk to you very soon.